Hey, what's up guys, my name is Cherno. Welcome back to my OpenGL series. So last time, which was quite a while ago, we talked about setting up a test framework, and we did set up a test framework and we actually implemented a clear color test. If you guys haven't seen that video, it's up there in the top right corner. I will reiterate a little bit about why we're doing this and where this series is going, just because I feel like it's been, I think it actually has been like 3 months since the last OpenGL episode, and I am sorry about that. We're gonna try and be more consistent from now on. So the purpose of what we're doing right now in the OpenGL series is, and the reason why I kind of diverted the series to actually set up this test framework, is because as we start introducing new concepts and you already know all the basics. I mean, we haven't covered absolutely every kind of what I would consider an OpenGL kind of foundational thing, right? Like, you know, we've covered textures, we've covered vertex buffers, we've covered vertex arrays. There's still some things we haven't covered, like, for example, we haven't covered frame buffers yet. So we haven't covered absolutely every kind of foundational OpenGL, I'm really missing a word here, pillar. Let's say pillar. Every kind of tool, I guess, that OpenGL gives us in order to actually achieve some kind of rendering task, right? We haven't learned about all of them yet, but we have learned about most of them. And with the stuff that we've learned so far, there is actually quite a lot of things you could do, right? And even this very, very simple API that we've constructed is enough to do so many things, right? So now that we've kind of learned about the basics of all of these different things that we can do, what I want to do is separate everything that we've learned out into tests that we can kind of switch between. And basically, but what a test is, again, definitely watch the test framework video if you haven't already, but it's essentially just like almost like an isolated application. It's just that instead of kind of actually making an application or a separate like Visual Studio project, so separate kind of executable program for each test, for each technique, if you will, that we've learned, because that would be just really annoying to kind of go through all of them. You'd have to launch, you would have to launch like separate applications every time, and that's just a mess, right? I want to just have one application, which is like our sandbox essentially, or our test like application, right? And then I want to have a menu there where you can kind of just switch between all of the stuff that we've done really easily, right? That's the whole goal of this. And at the end of the day, it's so that you can open up a single source file for like clear color, because that's the only one we've done right now, and just look at what you actually need to do to implement that, right? And of course, when we do get into more advanced techniques like lighting or shadow mapping or something like that, or like if you want to render your scene to a texture and then display it, or do like kind of post-processing on it, whatever, right? You can just open up the post-effects test or something and just look at the code and you're like, oh, okay, this is how I render to a texture and this is how I apply a blur pass over it, or something like that, right? The idea is to make everything really, really simple to read, because at the end of the day, that's what we want. We want like a library of techniques that we can just show off in the simplest way possible. And that's why I've set up this test framework. Okay, enough reiteration. What I'm going to do now is actually continue on with that, and implement because what we actually did is when we created this test framework, we had, you know, some geometry rendering like with the Cherno logo, just like basically a quad on the screen with the Cherno logo, but we deleted all of that code because we wanted to clear our application.cpp file and actually make it just about the tests. So now we're going to write a test which basically shows how to render a texture. And it's going to be pretty quick because we've already written the code before, but that's what we're going to do today. And then next time, we're going to hopefully move on to batch rendering, because now that we have this test framework, I feel comfortable enough to actually say, okay, we'll make a new test called batch rendering, and then I'll just show off how to actually render, a bunch of quads at once, like in a batch. Okay, so that's the plan. Let's dive into the code. So the first thing that we really need to do is, of course, I've got test clear color open over here. We have our test.h, which shows kind of, everything we need to know about the actual test framework here. But if we look at test clear color, that's really our test. That's our basic test. So what we can do is actually copy and paste that. The way I like to do that is just to open the containing folder for this stuff and then just copy and paste both of these files. And then I'm just going to rename test clear color to test texture or something like that. Yeah, I think test texture, maybe test texture 2D or something like that, because we will have more advanced texture tests in the future. And then if I go over here, I can just click on the test folder, hit this little refresh button, and then include both of these in my project. As simple as that. In the header file, I'm going to change test clear color to test texture 2D. And of course, I'll replace the, this is great. I'll replace the constructor and destructor with that. And I mean, we don't need this clear color private, so I will just get rid of that for now. And then if I Alt-O into this using Visual Assist to get to the CPP file, I will change this to test texture. And then, yeah, we can keep this stuff. And then I'll just do if I hit Control H, I can do a find replace for test clear color into test texture 2D. And Alt-O to replace everything in this document. Okay, cool, done. So that's pretty much it. We've got a blank canvas, I guess, for actually writing our tests here. I will probably keep setting the clear color to like, you know, black or something like that. And I'll keep the clear in there. And then of course, I don't need anything for the IMGUI stuff just yet. Okay, so there we go. We have a blank test. It's probably even nice, it would probably even be nice to just create a blank test kind of file. Or you can even set up Visual Studio like a template or something like that if you really want to. I never do anything like that. I just copy and paste files and then kind of refactor them, just rename stuff in them using find replace like I just did then. But essentially now we have a blank file to start off with. So now let's write the code that we need to actually display a texture. Now, I could write all the code from scratch. It's actually pretty simple, but there's an even easier way. Of course, I did have it written at one point. So if I just go to the GitHub repository for this project, which by the way, you can access if you become a patron by going to patreon.com/the Cherno, and then you'll get access to all of this kind of GitHub source code, which is great because it goes kind of episode by episode and it also helps support this series as well. We have all the commits from from each episode as separate commits. So if I just go to the one where I set up a test framework and just go to that specific diff for that commit, I could also browse the repository at that point, but this might be easier. If I look at application, I can see all the code I removed, which was basically our texture rendering test, right? So I can just copy and paste this stuff back into my Visual Studio and it should work. So let's start with all this kind of position and indices stuff. And in fact, you know what? I might just go and get pretty much everything just like that. We will have to bring some things out into members because they need to survive more than just the construction scope, obviously. But some of these things like float positions don't need to actually exist for longer than this scope because as soon as we add them to our actual vertex buffer, like that's it, they're done. Okay, so if we go over here in the constructor, I'm just going to paste in all of our code. And let's take a look at what we need to change here. So positions can stay, and I'll actually hit Control-Z just so it maintains the formatting. Good. Okay, so positions can stay, you know, indices can stay, blend and stuff like that can stay. We should have some kind of state probably that gets reset every time because obviously if one of these tests enables blending, we don't want to have to disable blending. You know, like at the end of this test essentially, so that might be a problem we might need to solve. But anyway, vertex arrays here, we'll definitely need to bring that out. Vertex buffer as well, layout can stay. I don't know why that's an error though, incomplete type. Okay, we need to include some of these things, of course. So let's include, let's see, vertex buffer, that, okay, vertex layout is probably its own thing, vertex buffer layout. GLM, which I have no idea what the include for that is. Actually, if we go back to here, I think it would have been at the top. Oh, whoops, that's clearly not the file. Do we see it here? No, let's just open the file as a separate thing. Oh, okay, that hasn't opened the file. Fantastic. If we just go back here and we go to this, we can look at the file. Actually, that's after I removed everything, but anyway, it should still be here. Yep, there it is. And if we go back here, we can just include GLM. And yeah, that looks like pretty much it, except for texture, which is kind of important for the texture test. So we'll include texture. Yeah, and then I think that's pretty much it. So we've got everything we need here. Obviously, we need to set everything up for rendering. So things that we actually would need for the rendering loop, if you look at this exact code here, and we had like translation and stuff like that as well set up. But what we really just need is the shader, the renderer object, which of course I think is just passed in to the render function, or no, it's not actually. So we need to get that from somewhere. Renderer get is all we really need, I think. Right, we did set that up. So this is why when it's a while between videos, I forget what actually exists. No, we don't have that. Okay, so that's interesting. But I mean, all it really is it's like we can just create a render object for now. And tell it what to do if we need to, because it's just literally like the renderer right now is just doesn't need to be like static or anything. It's just a set of commands that don't apply to any kind of state. What I mean by that is like the renderer doesn't have like, you know, any kind of member variables or anything, so you can just create a renderer instance per frame. Essentially, that'll be like free, right? Because it's just a stack object that has no size. It's got the size of 1. It's got nothing in it, and then you can just call the draw command, because really at this point draw is almost like a free floating function. It just happens to be inside the renderer class. It could just be static. Anyway, so back over here, yeah, I guess I'll copy most of this. We have all these sliders and stuff, right, that we had before, and the frame rate. So let's just copy that from IMGUI, and then we can put it, into on IMGUI render, which is over here. And then as for this stuff, I don't know what increment is. We probably don't need that. I think that's for the color. We'll grab this rendering code that we have and just put it into onRender at the end here. And then I think that's pretty much all we need. Yeah, translations. Okay, good. So now we can just start actually sorting this code out, because I think we've got all of it here now. Translation A, translation B, those were just, what even are those? Where did we make them? Here they are. They're just GLM vec3s. So if we go back to here, we'll make them here. So M translation A and B. Get rid of this. We'll set them up in the constructor. Let me get them again. So we'll say M translation A is 200, 200, 0. M translation B is 400, 200, 0. Okay, that's set up. What else did we need in here? So we need our shader, of course. This becomes M translation A. This becomes M translation B. And let's set up the shader. Okay, so the renderer, we can just, as I said, just make it like this. That's totally fine. We'd only need it to actually call this, and that's it. So we need the vertex array, we need the index buffer, and we need the shader. So that should be pretty easy. Let's actually go up here, and we might as well just include this stuff, I think, here. And we also need the texture. So vertex array, I'll call it VAO. We need a vertex buffer. We probably don't need the buffer. We definitely need an index buffer. What do we actually need? Okay, shader. Here we go, we do need the index buffer. So index buffer, IBO, or just I'll say index buffer. So we've got our vertex array, we've got our index buffer, we need our shader. And let's go back up here and replace everything. So shader becomes that. So let's just go up and initialize it here. So shader is this. Index buffer is indices in 6, so we can initialize that later. We might need to actually make these. You know what? I did make them stack variables, but I'm regretting this already. We'll just make them unique pointers, and that will be the end of that. So this is probably the first time you're seeing Cherno use smart pointers, but it's because that's the right thing to do in this case. We'll include memory so that we get access to all these smart pointers, and we will make all of these unique pointers, because having them as stack variables is kind of unnecessary, and we don't really want to do it that way. Okay, so now we can get rid of this and actually, yeah, you can, there's a few ways you could just make it unique, but you don't have to. That's just there to be consistent with the API, but I guess I will still use it. So std make unique. And then we'll do the same thing for the vertex array. MVAO equals, oh, that was helping me. Yep, make unique, and then index buffer as well. And then for the index buffer, which happened there, we will make it here, and we'll take the arguments and put them in here. Vertex array add buffer becomes VAO arrow add buffer. Shader, of course, is now different as well, and we've already made it, so we just have to do shader bind, shader set uniform. Texture as well we need to bring out in a minute. Yeah, we don't really need to unbind anything. Okay, so texture, let's bring out texture as well. std unique pointer, texture, and then we'll take the texture, std make unique texture. We don't need to bind it yet. We do need to bind it here though. So we'll do texture bind, this shader bind. So I guess the renderer doesn't bind the shader. Well, maybe it does. It does, so we don't need to bind the shader. That's because we need to set the uniform. Yeah, okay, so we will still have to do that. Set uniform. Yeah, proj and view is not a thing, so let's find those quickly. Here they are. We'll put them up here. Projection matrix you could of course just store as a, that doesn't change, so let's store that as a member. Actually, here they are here, so we probably, in fact, yeah, why do we have them? Oh, that was the original code, my bad. Okay, so, and view is set to that. Okay, great. So let's actually move these out. glm mat4, and proj, and view. So now, if we scroll up, we can just get rid of that and call that proj and view. And then over here, proj and view, VAO, which I think we'll have to dereference, index buffer, which we'll also dereference, and shader, which we'll also dereference because this takes in references, I think. Yes. Okay, great. And then this is the same, proj and view, shader bind, and that becomes, whoops, becomes shader. It's been so long. I'm almost struggling to type on this laptop because I'm really not used to this. Okay, there we go. I think that's perfect now. Oh, and of course translation A and B are members now. So we do that. Wow, okay, I think that's good. I should look over this code and see if it works. Let's maybe bring the shader down to where it's actually used. I should look through this code and make sure it works, but I'm just gonna leave it like this because yes. Yeah, with this as well, proj and view, I guess I could make them up here because that way they wouldn't need to be initialized twice. So proj is that, view is that. We'll definitely move this stuff down. Okay, there we go. So that's everything. Let's build everything and see if it compiles. I know this episode might seem a little bit boring, or just like, just doing stuff and not like talking about it maybe, but like this is just work that needs to get done, and I think the episodes are probably going to end up looking more like this anyway, because as we actually stop talking about stuff and start writing code based on stuff we already know, that can be quite a mundane task. So anyway, it is what it is. Okay, so this has succeeded. Let's actually see if this works. Obviously we haven't used the test anyway, so we definitely need to do that first. So if I go to application, all we really need to do is we create our test menu, and we just need to, once we have that test menu, we can register our test. So we have clear color as a test here. I'm just going to copy and paste that so that it becomes test texture 2D. And then if I go over here, this becomes test texture 2D. Texture 2D. Or I'll say 2D texture. And I think that's actually all we need. That one line of code in our test framework is enough to do everything. So let's just run and see if this runs. I'll be surprised if this doesn't crash, to be honest, because yeah. Okay, 2D texture. Okay, there we go. We crashed. Fantastic. Something's null, I believe, and it's in OpenGL. Okay, so this might be a hard error to debug. Let's go back to, let's change our thread to our main thread, so we can look at what's actually happened. So something's null. That's interesting. It's not happy with something. Well, our index buffer seems correct, and maybe our vertex array is wrong. But yeah, that's definitely interesting. So this is throwing a null pointer exception inside the graphics driver, I believe. What's the output? Yeah, okay. So that's fantastic. I wonder what has caused that. Let's look at our texture 2D test. That's not even showing up here. Okay, where is it? So all of this stuff. Okay, so it's just the of course, it's because our vertex buffer has been deleted. So the way that we store vertex buffers is that the scope of this actual class is the scope of the vertex buffer, because you can see in the destructor we delete it. So that's what's happened. It's trying to render from a vertex buffer that's null and been deleted. That's why the graphics driver crashes. So to fix that, of course, what we need to do is actually on the CPU side maintain our vertex buffer. For some reason, I thought that there is another design, of course, that you could have done, which is where instead of doing this. You could just kind of have your CPU side your vertex buffer class as just like a little kind of wrapper class almost that just sends data to the GPU, and that's all you need it for. And then you can discard it once the data's on the GPU. But of course, we haven't done it that way because doing it that way requires a different handle maintenance kind of system, right? Because obviously we still need to retain that renderer handle. So we basically have a one-to-one mapping between CPU side objects and GPU side objects. What I mean by that is that I have my vertex buffer object on the CPU. It is a mirror of what's on the GPU, right? Once it gets created, the GPU allocates memory. Once it gets deleted, the GPU deallocates memory, right? It's just one-to-one mapping. So if we do something like this, where we make it on the stack inside the constructor, once we reach the end of the scope, it gets deleted, and then our vertex buffer actually gets removed from GPU memory, which is bad if we're trying to then render to it. So I'm actually kind of glad this error happened. Because it gave me a chance to talk about this, and I didn't even think about it, to be honest. So m vertex buffer equals this. And then we just need to come over here. And that should be it. Okay. What is wrong with you? Oh, we need to... No, that's fine. Oh, yeah, what's wrong with that? Oh, I forgot the angular bracket. Okay, so add buffer, of course, is m vertex buffer like that. Dereferenced. And yeah, let's hit F5 again, and hopefully this will work. Okay, so 2D texture. Okay, look at that. And then we've got our two things being rendered, actually multiple times, and this is all good. It looks like these two are linked though. Oh no, translation A and B. Yeah, what have I done? Let's go back here. That's funny. I think I know what I did. So, oh, this looks good. Yeah, translation. I've got translation H twice. That's what was wrong. Okay. So now we should be able to control them independently. So 2D texture, and then here's this one, here's this one. Yep, fantastic. Okay, cool. So there we go. That is our test. If we go back, it deletes everything and clears everything, and then we can go back and clear color, we can go back, we can go to 2D texture, we can go back, and you can see how like every time essentially it will kind of create them and destroy them, and we actually have like a texture test now, as well as like a rendering multiple objects test, and then we have a clear color test as well. And I guess the point of all this is that if you look at this code, it's less than 100 lines, and it's so like concise, right? Like as in it's got like just everything we need really. Like this is everything you need to kind of create the shader, create the vertex array object, create the index buffer, create the vertex buffer, the vertex layout, everything that I need to set up those two objects, and the texture obviously and everything like that. Where's the texture? We can even kind of divide this a bit to make it even more clear. So I might even group this kind of stuff like that, because it's kind of creating the vertex array and everything. Then we have our index buffer, and what do we actually set? Okay, the index buffer gets set in the constructor. And then we have kind of the shader and then the texture, and everything's kind of grouped and really easy to use. Because they're all unique pointers, they will get destroyed at the end of the scope, so we don't even have to write anything in the destructor because we've, you know, used smart pointers kind of correctly. I made a video last week for the C++ series about safety and like about whether or not you should use smart pointers and what my opinions are on that, and how that kind of comes into teaching C++. So watch that video if you're more interested in what I mean by all of this stuff, because I don't know how, but I seem to have built up some kind of a reputation that I don't use smart pointers. I do. It's just that I don't think that raw pointers should be banned, because there are a lot of uses for them. In fact, I've used them in the test menu of this. But obviously for something like this, when I have a class and I just need heap kind of allocated memory to survive for the duration of that class kind of lifetime, then of course I'm going to use unique pointers. They add zero cost, basically. They add zero cost, we'll say, and they make programming so much easier. So anyway, but yeah, they'll get deleted automatically. On update, we don't even need anything. If we wanted to animate stuff, we could have that here. And then on render, you know, just shows, okay, here I am rendering one object, rendering the other object. You could annotate this with comments if you wanted to. And then we have kind of our debug pass, which is kind of just where we can render any kind of UI that we want to manipulate stuff. And it's just so clean and so easy. So that's kind of the point of all this. And of course, as always, the source code will be on GitHub if you want to take a look at it. Hope you guys enjoyed this video. If you did, you can hit that like button. As I said, access to source code and also helping to support the series can be done by going to patreon.com/the Cherno, and you'll get heaps of other rewards as well, such as kind of monthly hangouts with me, and like access to like a Patreon-only kind of chat on Discord. Heaps of stuff there, and it really does help support the series. So as always, thank you so much to those patrons for making this possible. Next time, we're gonna finally get into the batch renderer. I can't wait. I've been itching to do that for months. I will see you next time. Goodbye.